Hello friends, welcome all to the Max lecture series. So in this series we are learning how to apply single integral for various functions. So far we understood so many things. Now let us take the next one more beautiful question. Anyway, before looking to the solution, if you really understand whatever the content that I am delivering in this series, don't forget to click that like button and also share it with all your friends. Now take the function. The value of the integral is simply defined as -1 to +1 1 upon x power 2. This is 1 upon x power 2. So just to clearly write this one, this is 1 by x power 2 into dx is dash. They have given certain options like 2, -2, infinity does not exist. Shall we proceed? Yes, of course you all know how to integrate the given function. How will you do that? Let us take the function once. So what we are going to do is, the given function lies in between -1 to +1 upon 1 power 1 by x power 2 into dx. Let's see what will be the expected answer for this question. Can you please tell me what will happen for this? You can directly integrate this function, but whenever you are observing these kind of functions like 1 by x, 1 by x power, whatever the function that is lies in the denominator, or sometimes some logarithmic function will be given log x. So whenever you are observing something like, see, I am doing integration with respect to x, same variable is appearing in the denominator. Now under this situation, it is very important to cross check whether this function is appearing or whether the function is continuous or not between the given interval, like from -infinity plus infinity, or it may be a chance of getting discontinuity. What will happen is, if you observe the given function carefully, let me tell you, see, let us break this interval into two off. I am taking from -1 to +1, sorry, from -1 to 0, I am considering 1 by x power 2 into dx. Again I am breaking the limits from 0 to +1, again I am considering 1 by x power 2 into dx. See, always the purpose of using integration is in order to know the complete area of any functions. Now suppose if any function in the given interval is offering infinite value, then it is very important to observe there is some discontinuity in the function. Now if we carefully observe this function, when the moment we are replacing, anyway you all know if we integrate 1 by x power 2, it will give us what? Minus, see, let me show you, you can bring that x power 2 to the numerator with respect to dx. Now if you integrate this function, what you will be obtaining? It will give you x power, we know integration of x power n will be giving you x power n plus 1 upon n plus 1. According to this basic definition, if we apply integration for this function, this will give you the answer is what? X power -1 upon -1. So from this I can say it will be -1 by x. So simply we can write down the answer. But after that what will happen? We have to substitute the limits. See there, upper limit is approaching 0. Here also lower limit is approaching 0. You can break the limits into 2 off according to your convenience. There will be no any restriction for this. Now if you observe between -1 to +1, when the moment we are substituting 0, what will happen? 1 by 0 will be approaching this function to infinity. In both cases you will be obtaining this. One value will become finite, another only will become infinite. So what is the conclusion? You can do the integration. You will be getting -1 by x, then substitute the upper limit, lower limit will become will give you 1, whereas upper limit will give you infinity here. Here lower limit will give you infinity, upper limit will give you 1. So the conclusion is infinity plus 1 or -1, whatever, you will be getting infinity only. Yes or no? So the answer is infinity. But what we have to understand from this question, the thing is, do you remember in the previous lectures I was talking about the difference between proper integrals and improper integrals. What is the basic difference between the proper integrals and the improper integrals? Proper integrals in the sense, within the given limit, your function should be continuous. It should not produce any discontinuity. What is the meaning of continuous? See, suppose I am taking one function in the x and y axis. Suppose if you are considering a sinusoidal function, it will be traveling like this. Just assume it is traveling like this. So this function is continuous throughout the period. This function will be continuous. If you observe, sinusoidal function will be continuously traveling from -infinity to +infinity, and its value also bounded between -1 to +1. Yes sir, this function is called continuous function from -infinity to +infinity. Suppose I am observing one more function. That function is suddenly coming up to here. It is traveling like this. Suddenly after reaching this point, it is approaching to infinity. After that again it is continuing. See there, between this we don't have the continuity. Now what is the conclusion? Now I am defining, I don't know, let us take this function is f of x. I am talking about the limit is minus 2 to plus 2. If I am directly defining the integral limits like this, you have to observe between minus 2 to plus 2, if the function is continuous, if there will be no any discontinuity, then that is called proper integral. And the limits also finite. Observe, there are two conditions for proper integral. One is your limit should be finite, another one is your function should be continuous within the limit. Improper integral in the sense, either your limit will approach infinity or your function will approach discontinuity. Now if you observe this given function, that's why they are always testing your mastermind. You can directly integrate this function 1 by x square just by you can substitute upper limit and lower limit. But sometimes question will be always will be given easily. You can easily observe whether this function will be giving discontinuity or not within the given limit. See there, you know between minus 1 to plus 1 we have 0. If we put 1 by 0, automatically it will give you infinity. So discontinuity will appear. Conclusion is, it is very important to observe the properties of improper and proper integral, and there is no point of bothering about it, because by practice after sometimes what will be happening is same function they will be giving a little bit twisting and again it will be repeated. So directly by observing the question itself, yes, this is improper integral, this is proper integral, this is continuity, this will be producing discontinuity, this is even function, odd function, everything will be automatically appearing in your mind. So don't be bothered about it, just practice as many questions as possible in order to get the clarity about the functions. Okay, anyway, this given function is an improper, this given integral is an improper integral and its correspondent answer is infinity. Correct answer is option C. So this is all for this lecture. Remaining things we will see in the next class. Thank you all.